Welcome to How to Succeed in ECE Without Even Trying. I'm Dr. Linda DeBrenner, and today I'm going to do a quick K-map example with 3 variables just to illustrate the key points of using K-maps to minimize digital logic circuits. So here's a function. F of ABC is equal to the sum of minterms 0, 1, 2, 3, and 6. And I want to first go ahead and plot those on the K-map. So I'm going to choose to put the variables A and B along the top and C down the side. And what that means is that this row corresponds to C being 0. This row corresponds to C being 1. These two columns correspond to A being 0. And these two columns correspond to A being a 1. Similarly, the middle two columns correspond to B being a 1. And then these last two columns and the first two columns together correspond to where B is equal to 0. So notice that the K-map is actually kind of wrapping around to form a cylinder, if you want to visualize it that way. What this means is that every time we have a square that shares an edge with another square, we would say these two squares are adjacent. So let's go ahead and plot these minterms, and then we can use that as an example of what we're doing. So the minterm 0 is right here, minterm 1's here, 2's here, 3's here. This one over here would be 4, which corresponds to A, B bar, C bar. This would be 5, and here is 6. So let's go ahead and write in the 6. The best way to do this, of course, in my opinion, is to go ahead and memorize the order of the minterms. So 0, 1, 2, 3, 4 up in the corner, 5, 6, and 7. A quick check is make sure that the one you label 7 corresponds to the case where every variable is a 1. Okay, so now that we have our minterms plotted, it's time to go ahead and do the groups. Now, you do not just start with the biggest groups. That would be, sometimes it will give you an incorrect result. So what we want to do instead is to look for the minterms that have the fewest adjacencies. So I would ask myself, is there any minterm that does not share an edge with any other minterm? Okay, and in this case, we do not have a minterm that is all by itself. So it's always adjacent to another square. So then I would ask, is there any minterms that only have one adjacency? Now, sometimes you might need to go through many of the minterms just to check. Sometimes you can see right away. If you see one that has one adjacency, like this one, it's only adjacent to 1, then I know I can go ahead and start with this term. Now, I might have another term that also has one adjacency, and it would not matter which one I started with. So let's just quickly go through and note that minterm 6 is adjacent to minterm 2 because they share an edge. Minterm 2 is adjacent to 6, 3, and 0 because it has 3 edges. Minterm 0 is adjacent to minterm 2 and minterm 1. Minterm 1 is adjacent to 0 and 3. And maybe I've done them all. 3 is adjacent to 2 and 1. And I think I've done them all. In any case, we have no minterm that's adjacent to only 0. I mean, not adjacent to any other minterms. We have one minterm that's adjacent to one other minterm, so that's where we'll start. Then we ask ourselves, is that in a group of size 8? Well, 8 would be the whole K-map in this case. So the answer is obviously no. Then we say, is it a group of size 4? So is it in a group of 4? It could be either the square of 4 or a rectangle of 4, but it must be a power of 2. So 3 is not okay. We cannot group those together. Okay, so that would be wrong. So instead, we're going to look and we can see that this minterm 6 is adjacent to 2, so we can group those together. And what that in effect is doing when we group them together is like using the Boolean algebra expression xy or xy bar is equal to x. So in this particular case, This corresponds to A, B, C bar, or A bar, B, C bar. In other words, you're going to eliminate that A term. And so we can look at this group and see this group is where B is equal to 1 and C is equal to 0. And I just go ahead at this point and write it down at the bottom. So we have B, C bar, and then I go and look for the next term. Well, you may remember, you may have to figure it out again. There's no other min-term that's adjacent to one other, only one other, but we have 3 that are not covered that are adjacent to 2. So it doesn't matter which of those we choose. I will choose this one, doesn't matter at all. And ask myself, is it in a group of size 8? The answer is no, that would be all ones. Is it in a group of size 4? Yes, it's in this group of size 4. Okay, so let's go ahead and put a group there. Size 4, and that corresponds to A being a 0, so that term is A bar. So that is our function minimized using a 3-variable K-map. It's best to work many problems, and I would encourage you to try the problem, watch the solution, then the next day try the same problem again.